The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone. Thank you for joining us today. I'm Kelly Pirtle with NOAA Communications in Norman, Oklahoma, and I'm also a member of NOAA's Central Region Collaboration Team. I'm your host for today's webinar. And in this virtual world, things are kind of always there's always something unexpected. And our person who hosts the slides, our wonderful collaboration team coordinator, she's having computer issues. So we're hoping that she'll get back up very quickly. Meanwhile, I want to introduce what we're doing today. Today's 3-minute thesis webinar has been organized by the NOAA Central Region Collaboration Team to share experiences and information from NOAA staff about tropical weather. I'm looking forward to learning more, and I hope you are too. The webinar format that we're using is based on a model used by universities across the country as a way to briefly share information about a project, initiative, or research. Each presenter you will hear from today will have 3 minutes and 1 slide to cover their topic. It's pretty challenging to do it in such a short time. You can see from the outline we have a variety of topics divided into 3 sections with presenters from different parts of NOAA. After each section, we will take a break for questions from you, our audience, for each group of presenters. And at the end, we will have a few minutes for all panelists to respond to your questions. At any point during the presentations, please submit your questions in writing using the questions pane of the GoToWebinar panel. Bethany Perry, our coordinator for the NOAA Central Region Collaboration Team, will collect them for our Q&A sessions throughout the webinar. We are recording today's webinar, which is a good news, and it will be posted early next week on our homepage, www.noaa.gov/centralregion. We'd love to get your feedback on this event. Please take a moment at the conclusion of today's webinar to complete a very brief survey. And before we get started, I'd like to thank 2 regional collaboration teams for their help pulling together this excellent lineup that represents some of the many ways NOAA serves our country through science, service, and stewardship. As you might imagine, we don't deal with tropical weather much in the central U.S., but a lot of people were interested in this topic, so we turned to our friends from the NOAA Gulf of Mexico and the NOAA Southeast and Caribbean Regional Collaboration Teams for help identifying topics and speakers. Their input was invaluable, and we are grateful for that. All right, it looks like Bethany, bear with me, I'm sorry. Bethany's not quite up yet, she's still trying. So I'm going to switch presenters. Okay, maybe she is.
Okay, I'm trying to pull up the slides real quick. So sorry about my computer crash 2 minutes before our start. But if Shirley can share her screen by the time we're ready for the next, well.
Okay, I'm going to have Shirley share. Okay, I'm making Shirley the presenter.
Okay.
And Shirley's going to show us her slide while I introduce her. Okay, we're going to start our webinar with NOAA researcher Shirley Murillo, the Deputy Director of the Hurricane Research Division that is part of the Atlantic Oceanographic and Meteorological Laboratory in Miami, Florida. She oversees the science research objectives and the personnel who conduct the research. Shirley has participated in many NOAA Hurricane Hunter flights as a scientist, her first one back in 1998 into Hurricane George. Let's hear what she has to say about new technologies for sampling hurricanes. Take it from here, Shirley, when you're ready. We can't hear you.
Let's see, can you see my screen? And
yes.
Can you see the slide?
Thank you, yes.
Yes and yes. All right, so let's get to it. So thank you for that introduction. Hang on, I start my own timer here. Yes, thank you, everyone. Every hurricane season, the researchers at the Atlantic Oceanographic and Meteorological Laboratory at HRD participate in Hurricane Hunter flights. We are the science crew that design the flight patterns, perform the data quality control, and transmit the data that goes into the forecaster's desk and into the weather models. These flights are conducted twice a day, one in the daytime and one at night. Stay tuned. At the end of this webinar, you will hear from one of our pilots. So I want to share with you 3 innovations that AOML is pursuing to enhance the way that we collect data inside hurricanes. Let's start with the Doppler wind LiDAR here on the right. I'm sorry, on the left. I'm showing you an image of the instrument mounted on the side of the aircraft. The LiDAR uses laser technology to measure aerosols in the atmosphere. It complements the tail Doppler radar that sees precipitation in clouds and produces radar reflectivity and velocity. The LiDAR produces a curtain, sort of like a curtain, of wind profiles in the hurricane environment. We've tested the LiDAR on a few storms and see the benefit of the data that it's collected. We're hoping to try a different type of LiDAR this season, one that is mounted on the belly of the aircraft. In the middle here, I'm showing you an uncrewed system. This is called the Altius 360. So the Altius 360 it's an uncrewed aerial system that will help us collect critical data in the lower part of the atmosphere near the ocean surface, where it's unsafe for a manned aircraft to go. We will launch the Altius from the P3, where we will have pilots controlling the UAS and safely maneuvering it. There are lots of thermodynamic processes that are happening in this part of the atmosphere that has rarely been sampled in this manner. So we're hoping that this type of UAS is going to advance our understanding. Staying on the theme of uncrewed system, the images on the right show our ocean glider. AOML, along with other partners in the academia and integrated observing system offices throughout NOAA, have adopted this new technology to sample below the ocean surface. AOML launches gliders in hurricane-prone areas to collect data on the role the ocean plays in hurricane intensity. The data collected from the gliders show us how quickly the ocean mixes and how long afterwards it takes the ocean to recover. The gliders are piloted remotely and can dive deep in the ocean or remain on the surface. So these are just 3 examples of the new technology that we continue to test and hopefully improve the forecast guidance and improve our understanding of hurricanes. Thank you.
Thank you, Shirley. Now let me see if we can switch back to our regular presentation. Bethany, is that working?
You have to make me the panelist and then we should be ready to go.
I thought. There we go.
Okay. All right, can you see Shirley's slide now?
Yes. Okay.
Okay, cool, then we're ready. Thanks so much for your patience, everyone.
Awesome, yes, thank you. Thank you, Shirley, for being flexible there and sharing your screen and your excellent presentation. A lot of research over the years has helped improve hurricane forecasts. Next, we're going to hear from someone responsible for making those forecasts. John Cangialosi is a senior hurricane specialist at NOAA's National Hurricane Center in Miami, Florida, where he issues track, intensity, and wind forecasts, as well as associated watches and warnings for tropical cyclones in the Atlantic and the eastern North Pacific Oceans. Tell us more about that, John.
Sure, will do. Thanks, Kelly. So I am going to talk to you about the 3 questions that guide hurricane forecasting. And Bethany, if you advance the slide a little bit, there's something we have to do first before getting to the questions, and that is a tropical cyclone analysis. Now, when it comes to the analysis, we need to find the center of the circulation of the storm, which can be challenging. We also have to estimate the intensity, both in terms of the maximum wind speed and minimum pressure, and evaluate the wind field in terms of the tropical storm and hurricane force winds and the radius of maximum wind. And to do that, we're going to take advantage of some of the data that Shirley just mentioned, like aircraft data, but also use satellite, radar, surface observations, and more. All right, let's get into the questions. First one, where is the storm going, or the track forecast. Now, the motion of tropical systems are largely controlled by large scale or synoptic scale features like ridges or troughs and jet streams in the atmosphere. And the global models we all use do a pretty good job at resolving those features and overall steering flows, and that has resulted in very much improving Hurricane Center track forecasts over the years. So if you take a look at the chart there on the lower left, you'll see each line by decade getting lower and lower, indicating improving track forecasts from the Hurricane Center. And probably the most famous way people see our forecast at the Hurricane Center is that cone graphic you see there near the middle of the screen. And that forecast, as I just mentioned, has gotten better and better over the years. All right, second question. How strong will the storm become, or the intensity forecast? Now, this is harder. Intensity forecasting is more difficult because it's a second order problem, or it depends upon the exact track. It also depends very critically on the wind, temperature, and moisture patterns, both near the core of the storm and what's happening in the environment, both in terms of the atmosphere and the ocean. And because of the complexities here, progress for the intensity forecasting from the Hurricane Center has been a little slower than that of track. All right, the third question, how big will the storm get? And this is something most people don't really think about, especially in the general public, but it's an important one. It's also a challenging one to forecast, as the size forecast has not evolved because the models that we use for track and intensity are not skillful yet to really predict this. So forecasters at the Hurricane Center still fall back on some basic concepts. As storms gain latitude, they typically get bigger. As storms get stronger, the outer wind field typically gets larger. Forecasters will also consider effects from friction, extratropical transition, and asymmetries of what's happening in the environment when making a wind radii or size forecast. So these are the three questions that really guide hurricane forecasting. And from here, you're going to hear more about some of the impacts and how we communicate these forecasts down the road. So thanks, everybody.
Thank you, John. When a hurricane occurs, it's not just the powerful winds that cause destruction and harm. One of the greatest threats to life actually comes from the water in the form of storm surge. We're going to learn more about that from our next speaker, Jamie Rhome. He is the storm surge specialist and team lead at NOAA's National Hurricane Center in Miami. He oversees the National Hurricane Center's Storm Surge Unit, which produces official storm surge forecasts during tropical cyclone threats to the U.S., supports the nation's hurricane warning program, and facilitates post-storm response and recovery efforts. Jamie, take it away.
Hey, good afternoon, everyone, and thanks for having me here. Thanks for being here. So the reason John and I are going back to back is the missions of the branch of the Hurricane Center he represents and the mission of mine really go hand in hand, as you need the wind forcing and the science behind that to really drive the water. And storm surge is really a lot of the intersection of science and policy, and these images here are meant to sort of depict that. And the reason being is in this country, the primary reason we evacuate, I'm talking about large evacuations of hundreds of thousands of people, sometimes millions. The reason that we evacuate in this country is due to storm surge threat, and that's due to the fact it's historically the #1 killer in a hurricane. We just, owing to progress on the wind side, we don't lose a lot of people in wind. Most of the deaths now are drowning due to storm surge primarily, and secondarily freshwater flooding. So the way that we mitigate this is working with FEMA, the Stafford Act, statutory authority that affords us the ability to do this, to basically outline risk models, risk modeling, and outline the risk, and from that work with emergency managers to develop evacuation zones, who evacuates, and planning. So this gets into hospitals, shelters, transportation analysis, how long does it take to evacuate, and it speaks to clearance times. Once we have those predefined plans, a playbook, if you will, that defines how this nation evacuates, and again, I'm talking about large-scale multi-state evacuations, we drop down to the more commonly known part of what we do, which is to provide the real-time forecast warnings and decision support, which go into deciding which of those pre-existing zones are evacuated, and when. And then finally, the last part of our mission here at the Hurricane Center is once a storm actually strikes. So we're not talking about the forecast part. Once it actually hits, the long path of recovery is basically enabled by this immediate hindcast. So a hindcast is basically taking the same storm surge model, and instead of forecast mode, it's now in sort of historical mode, looking back to recreate the storm surge and flooding that actually occurred. And this is to support response and recovery, the deployment of personnel, the deployment of federal assets, the movement and response of personnel into an area to recover, the availability of federal funds to assist communities as they get back up from a hurricane. So this is to show you the entire duration of what we do, not just before a hurricane forms, but after. So that concludes my presentation. Thank you so much again for having us today.
Thank you so much, Jamie. We will now take a few minutes to address some of the questions submitted from the audience. Remember, you can type your questions in the questions pane of the GoToWebinar control panel. Bethany?
Thanks, Kelly. So the first question I have is for Shirley. What's the difference in the data between the Doppler wind lidar and the SFMR?
So the SFMR measures or derives a wind speed, and it derives it by measuring the brightness temperature of the, how would I say this, the foam that is created. So you have wind, that wind blows over the ocean surface, it creates waves, those waves create foam. That foam is measured as a brightness temperature, and we can derive a wind speed through that. And it's only it's a point measurement of an instance of the wind. A LiDAR can give you, as I mentioned, easily a curtain, so imagine, from the height of the airplane or even above with the Doppler wind LiDAR, you can point the laser to measure above the hurricane all the way down. You can see my hand, all the way down to the ocean surface. So it gives you a whole profile of wind speeds.
Wow, thanks. So the next question for John, it says, if the storm gets bigger as it changes latitude and the wind field grows as it gets stronger, how do you tease that apart?
Yeah, it's pretty tricky, Bethany. So usually when storms gain latitude, especially when they're getting to latitudes near the United States, they usually don't get stronger. In this case, they usually just start to expand outwards. So sometimes we see the pressure actually staying low or even falling, but that's because the wind field just sort of stretching out. And that's definitely true from basically the Carolinas northward. The forecasters, I'll say that it's a blend of art and science, honestly. The models they've advanced so much for track, but when it comes to predicting size and intensity, we still rely a lot on just knowledge and a little blend of art and what we've seen through experience in trying to get this right. And every year we run a verification on both our track, intensity, and a little bit on size. And when it comes to track, we're about as good as the best models. When it comes to intensity and size, we're better than the models because of that blend of art and experience that I mentioned.
Great, thanks, John. And Jamie, here's a question for you, and I have a hunch our next presenter might start to touch on this just a little bit. But what are the biggest challenges or opportunities for improvement you see when coordinating, planning, responding in support of emergency managers? And what is the most important information that they ask for?
Communication. The science has gotten so good, not that it's perfect, as John alluded, but the science has basically outpaced the ability and knowledge and the way we communicate our products, the words we use, how we convey it, decision support. All of that is sort of catching up to the science that Shirley and John have outlined, because owing to recent advancements in research and development on the physical science side, they've really made massive strides on the nature of hurricane predictions. And now turning those predictions into societal benefits is where we're focusing the bulk of our energy. And the number one thing emergency managers want, like during a storm, really they want reassurance. I mean, this is a career-ending decision to make an evacuation call. because you never nail, you never precisely nail an evacuation. It's just impossible. And I mean, you all know what it's like to live in this country right now. People are angry just waking up in the morning. So you can imagine if they're asked to leave their community and not come back for 2 or 3 days, these folks are livid. So often the decision to evacuate is a career-ending decision. And so what people are really looking for in a storm is just reassurance that it's the right decision.
Wow, that really puts it in some perspective. Thank you, Jamie. And thanks to the audience for these great questions. I know there's a couple more, and we're going to hold those to the end where we'll invite all of our speakers to come back, and we'll do some wrap-up questions. So again, thank you guys, and Kelly, I'll pass it on to you.
Thank you, Bethany. We'll now transition to our next group. When hurricanes threaten coastal communities, local officials rely on forecasts and guidance from National Weather Service forecast offices. Jennifer Hubbard is a senior forecaster with the Tampa Bay office in Florida, where she also serves as the tropical program manager. She will share with us information about their tropical weather decision support services. Jennifer, tell us more about how a WFO works with their local partners.
All right, thanks. Well, for anyone watching that's not familiar with impact-based decision support services, the National Weather Service offices have a list of partners that they provide forecast briefings to that detail the impacts expected with a weather event. And at the local level, these partners include emergency managers, local government agencies, and other federal agencies at their field offices. So for tropical events, there are numerous impacts that we have to make sure we cover in these briefings. Now, this is an example of the hurricane threats and impacts graphics that an office will produce once they're under the 5-day error cone. It provides a quick overview of the threat levels expected with each impact listed. We start with this, then we take a deep dive into the specific details for each hazard in the briefing. So for example, with storm surge, we'll give the reasonable worst case scenario that's expected for the surge levels for each county's coastline. But the impacts aren't the only story in these briefings, as they are highly dependent upon the exact track and intensity of the storm itself. The other main component is making sure to manage expectations about the timing, uncertainty, and addressing any track changes that may occur. Because our partners make decisions, such as evacuation orders, based off of timing triggers, we have to be sure to address not only the timing of the entire system itself, but also the timing of each individual impact, as rainfall, for example, may begin days in advance of the actual storm. Timing may also be a factor, such as in this example, where the system was moving over and away from the area, but then expected to loop and return. We broke up the forecast here into 2 phases to help express those timing expectations, but also to convey the level of uncertainty within each phase. The first half of the forecast had a high level of confidence, but there was a greater level of uncertainty with the second half of the forecast, as there were numerous environmental factors influencing it. We detailed that uncertainty as well as the changes that would subsequently happen to the impacts. And this ties in with the track adjustments as well. Tropical forecasting already has some uncertainty built into it, as it incorporates both ensemble and probabilistic data. So larger track changes don't typically cause huge wholesale changes to the impacts from one forecast cycle to the next. But it is necessary to highlight the possibility of this happening to our partners in advance, so that if and when it does happen, they don't feel like they've been caught off guard. And finally, in an active season like 2020, where almost the entire eastern US and Gulf coastlines had a tropical event, some even having multiple landfalls, we beat the fatigue of it all by remaining the calm and trusted voice of reason to our partners. They know that they can count on us to tell it like it is without any hype. They also know that we will contact them the minute we feel there's a credible threat to the area, so that they don't have to worry over every single system that develops, or even any potential system that shows up in the models. Thank you.
Thank you, Jen. Next, we'll hear from Dennis Feltgen, the Communications and Public Affairs Officer and a spokesperson for NOAA's National Hurricane Center in Miami. If Dennis sounds like a broadcast meteorologist, that's because he was one for nearly 30 years before joining NOAA. Since 2007, Dennis has been helping the NHC handle the surge of media that descends upon the facility prior to and during landfalling storms. Dennis, tell us how you do it.
Thanks, Kelly, and good afternoon, everybody. You know, every hurricane season, we have a story to tell. It's a breaking reality story about something that's capable of doing harm to people and property and with long-term psychological and physical effects. Now you got to sell the story. But how? Well, the answer is knowing who your audience is and how to reach them. Well, your audience are the folks in the high-rise apartments and condos, the single-family duplex and mobile homes. They're the businesses down Main Street. How do you reach them? That's where the media comes in. And it's all local, local, local. Even with the Weather Channel and Weather Nation, most people still get their information from their local TV weathercasters and meteorologists. He or she's in their living room every night with an established trust. What we as an agency need to do is use that trust to effectively get to that same audience. So first, find out who they are and get personal. What I did was create a spreadsheet and update it several times a year and share it with NOAA comms. And that spreadsheet contains the contact information of every TV weathercaster at every broadcast station from Texas to Maine and one row of states inland from there. I also got the generic email address and phone number for the news assignment desk of all those stations. So during the hurricane off season, reach out to them, especially via email. Tell them what's new this year. We write up a document every year on that very topic. Make sure they all get it and understand it. Offer up media interviews, especially during conferences and National Hurricane Preparedness Week. In other words, make yourself available. Then, when there's a direct threat of a hurricane, use that mailing list immediately to reach out to the weathercasters and their assignment desk to alert them to the media pool for TV or for Skype interviews. They will use that opportunity and you will have their audience. And there's another way to reach the audience. It's new in the last 10 years. That's social medias. And one of the most powerful tools to come along is Facebook. The TV and the print and the radio can get their very latest information and place the Facebook Live broadcast on their respective websites, expanding your reach. It's a one-on-one conversation between you and the audience and a unique opportunity to get your message across. Do a couple of them a day when the new information becomes available. As for Twitter, it's an excellent tool. 240 characters can say a lot, but always have a link and a graphic to get your message across. And yes, finally, the graphics. This isn't radio. You gotta have a visual to ensure that the media, and thus your audience, are all on the same page of the story. The graphic has to be simple and effective. We've got the track forecast cone, the storm map, inundation map, the arrival of tropical storm force wind maps, all good, simple, and important visuals. But the most important thing you want to sell, it's the key messages, a simple graphic wrapping it all together with several bullets. All the media has to do is cut and paste the bullets and run them in a crawl or place them in the script of the news anchors. Bottom line, if you sell your story, you've done your job and saved lives. I'll stop here. Thanks for the opportunity.
Thank you, Dennis. Stay on for our next question session. We've heard some really interesting information so far, and I hope you all are enjoying it as much as I am. We will now take a few minutes to address some of your questions. And if you have a question you haven't asked yet, type it in the questions pane of the GoToWebinar control panel. Bethany?
Thanks, Kelly. Thanks, Dennis and Jennifer. That was great. Jen, there's a question for you about the impact graphics that we were showing. And this person wondered where or if they could find those someplace.
Well, I have provided a link to them in the bio section of the webpage that you'll provide here. But essentially, if you just search the Weather Service pages for the tropical pages on any of the at least Southern region websites, all the local offices have a tropical forecast page that includes them, and I believe it's also available off of the Hurricane Center websites.
Great, Jen, and thanks. That gives me a chance to let folks know that we do have some more information about these various presentations in the link that Jen just mentioned. If you go to www.noaa.gov/central region, you'll see a page there dedicated for this particular webinar. And Dennis, question for you. What are some of the best practices for using Facebook Live?
Well, believe me, we've done trial by fire. We started using it back with Florence. So, we've learned that for best practices, use a gimbal. I'm notorious for not having a steady hand, and it shows if I'm not using the gimbal. Unfortunately, during the last 3 years, we've actually burned through 3 gimbals, and most of them are because of software problems. They're good, but oh boy, they still got some problems. So we actually went to a tripod lockdown during the last 4 or 5 events of the Hurricane Center this past season. So that's something to keep in mind. You got to keep your stuff fresh. So make sure you do these often enough. And of course, closed caption them. If you don't close caption them, watch the comments page, because they're going to come after you with both barrels, and rightly so. And fortunately, Facebook, I'm very impressed with it. It has a very good auto caption feature. I can't even remember a single instance this year where I had to go in and make an edit. So something to keep in mind.
Wow, that's great to know. That can always be a bit of a challenge. All right, Jennifer, one more question for you. How do you handle it when partners are questioning a new model run that just came in that's vastly different from the official forecast that you have been briefing them on?
Well, hopefully, as I was talking about, we do try to address the potential for any track changes that may be occurring, so that they are aware that that's a possibility. And hopefully, if they see that coming in, then they're not, trying to jump right on that forecast, that they know that we will eventually trend if that continues, or more than likely it might just be a single run outlier that isn't going to actually have a long-term impact on the overall forecast. So we try to just keep it to the official forecast track, but hopefully we have already addressed some of the changes that are possible.
Awesome, well, thank you. And again, a couple of questions we haven't got time for right now, but we'll hold those to the end. And thank you, Jennifer and Dennis. And with that, Kelly, I'll pass it back to you.
All right, thank you, Bethany. And thank you, Dennis and Jen. We'll now begin our final section with a couple presentations about what happens after the storm. Next up is Kyle Ward. He is a navigation manager for the Office of Coast Survey. He will talk with us about how NOAA helps ports get commerce flowing after a hurricane. Kyle is located in Charleston, South Carolina, and his area of responsibility covers all Atlantic coast ports from North Carolina to Key West. Kyle?
Thank you for that intro, and that's a really big target area during hurricane season. Luckily, last year, most of the action went to the Gulf. I personally am hoping that stays the same for 2021. So my office maintains nautical charts for safety of navigation. We do this by applying our partners' data and our own data to update the charts, like aids to navigation maintained by the Coast Guard and channel surveys from the Army Corps of Engineers. We also have a fleet of small boats and ships that collect bathymetry data to update our charts. When a hurricane hits, we work with these two agencies, Coast Guard and Army Corps, and Marine pilots to help open up the ports. Now, if you're not familiar, Marine pilots are mariners with special knowledge of a port that they operate in, and most large vessels are required to hire a pilot when coming into port. When gale force winds are forecast within 24 hours of hitting a port, it is usually closed, and this means that no large vessels are allowed to come in or leave the port, and most are required to leave before the storm even arrives. And then the damage report, the storm goes through and the damage reports start to come in. First, we hear from the tugs and the pilots because they stay on the water, and later from the Coast Guard, and they'll deploy boats and helicopters to survey damage on the surface. And as those reports come in, the 4 groups mentioned there in the center of the graphic begin to discuss what's needed to fully help the port recover. If the port sustains significant damage, like storm surge, like we heard about earlier, over the port facilities, any high wave action, lots of debris is seen in the water, or and that could be boats or containers from the container terminals, then we know that a full object detection survey will be needed to find any debris that could pose a hazard to navigation. So the map on the left shows a planning document that we used after Hurricane Sandy in 2012 to denote the survey areas that the Army Corps of Engineers and NOAA would be assigned. And the NOAA ship Thomas Jefferson, pictured in the top center, and just to the right of that, the small boat is a navigation response team. Both of these were used in Hurricane Sandy. And we also have survey equipment that can be placed on a vessel of opportunity. And in the upper right-hand corner, it shows our equipment on a Coast Guard small boat down in from Hurricane Irma down in Key West. So the products that all of these units would be able to collect are shown in the graphics at the bottom of the slide. So in the bottom center, there's an image of the Charleston entrance channel. And then just to the right of that is a sunken boat that would be seen near a dock. Once the surveys are complete and the obstructions are identified, the captain of the port makes the call to allow vessels to start moving again. So what's the rush? Why do we expend so much effort in opening a port quickly? Well, as you may know, each day a port is closed, millions of dollars of revenue is lost. But more importantly, it's urgent because a lot of times the relief supplies that an area will need to recover will arrive via boat. And we saw that in Puerto Rico after Hurricane Maria devastated that area in 2017. And depending on the area, the priorities may change, but generally they're looking for fuel, food, and to allow any people that are out on cruise ships to come back. Thank you for your attention. Appreciate it.
Thank you, Kyle. Hurricanes can lead to serious economic impacts for fishers and their communities. NOAA Marine Fisheries Service administers disaster assistance under 2 statutes, working closely with state officials, Congress, and the Secretary of Commerce. Our next presenter, Michael Jepson, is the Social Science Branch Chief at the National Marine Fisheries Services Southeast Regional Office in Florida. Mike, tell us how your office helps make that happen.
Thanks for that introduction, and thanks for the opportunity to talk about NOAA Fisheries Disaster Assessment. And I'm never quite sure that people are aware that we do these assessments, but we are mandated through the Magnuson Act and the Interjurisdictional Fisheries Act to understand the impacts to the fishing industry from revenue losses and damages from these disasters. Certainly since the mid-'80s, NOAA Fisheries has had over 100 disaster requests, and they really seem to be increasing almost exponentially in the last few years. Most of the disasters that we do in the Southeast are primarily from hurricanes, but they also come from breezes in the shrimp fishery in the South Atlantic, red tides, and like in the recent one in Florida's Gulf Coast, or extreme flooding like from the Bonnie Carey spillway recently in the Northern Gulf. But what I'd like to focus on is primarily kind of the 2 ways that we conduct our assessments. And I want to start with the one on the right from Section 315 of the Magnuson Act. And under Section 315, the Secretary actually declares the disaster before we do the assessment. Once that happens, we have 60 days where we have to collect the data, analyze it, put it into a report, provide it to leadership. It then goes to Congress, and then Congress determines how much money they will allocate. And then once that's done, the states submit spending plans, and then the money is allocated to the states. So it's a little different in the sense from the under Section 312, because we include not only commercial fishing harvesters, but we look at other businesses like seafood processors, bait and tackle shops, charter fishermen, and the such. Under Section 312, the assessment is done primarily on commercial fishing harvesters, and we look at their revenue losses, and they have to meet a threshold of between 35% and 85% of losses in a particular fishery. If it's under 35%, a disaster is not declared. If it's over 85%, it's an automatic disaster. But in between, the Secretary will make a decision as to whether to declare a disaster or not. One thing I did want to point out is that under Section 315, when we do these assessments, the broader assessments, usually for hurricanes, we used to send people into the field. And I've been on several disaster assessments and in the field, and I just want to say it's remarkable when you go into these communities, it's almost like a war zone, and the destruction is unimaginable sometimes. But also what is remarkable is the resilience that you find with the people in these communities, how they come together to overcome this disaster. And that's really kind of a highlight of having that experience. And I've seen it many times in many communities. And it is just remarkable. So that's kind of the different how we do our disaster assessments. And with that, I'll answer any questions. Thank you again.
Thank you, Mike. I'm certainly enjoying learning about different parts of NOAA. Have you ever wondered what it's like to fly a plane into a hurricane? Our final presenter is going to tell us about her experience doing just that. Lieutenant Commander Becky Shaw is a WP-3D pilot in the NOAA Corps. She was commissioned in June 2020 as an inter-service transfer from the Navy after 11 years of service flying multiple aircraft as a test pilot. New to NOAA, she flew her first hurricane penetration flights on hurricanes Delta, Zeta, and Eta during the 2020 season. Becky?
Hello, and thank you for that introduction. At the Aircraft Operations Center here in Lakeland, Florida, we have several aircraft that perform missions for NOAA. I fly the WP-3D Hurricane Hunter as tasked by the National Hurricane Center to collect data and fixes on the center of the storm. We also conduct research missions for the AOML Hurricane Research Division and NOAA's Environmental Modeling Center. So who makes up this crew? Like who flies aboard the P3? So the crew of the Hurricane Hunters is a diverse group. We have, in the flight station, we have the flight crew, senior pilots like myself, and flight engineers who are flying the aircraft through the storm. And then as you go into the cabin, we have a NOAA Corps navigator who's looking at the timing, making sure that we're at the fixes on time, and a meteorologist who acts as a flight director, who's sort of running the show to make sure we're entering the storm safely and coordinating the airborne science. Who's coordinating the airborne science. We have an AVAPS operator who's launching drop zones, a technical operator who's looking at all the instrumentation, making sure all the data is coming through appropriately, and scientists in the back, crew from HRD, who are interpreting the science and making sure that what we're collecting in real time are the appropriate parameters to send off the aircraft. So that's everybody on board. And as far as the instruments, well, you saw on the first presentation today, I'm one of AOC's test pilots, and I actually just finished a week of flight tests where we got to do some test certification for the Altius, and I am so excited to launch that technology this season. Some of the other things that we are currently flying with are radars that allow us to collect data on turbulence, wind speed at the surface, rain rate, and then the drop zones that will measure temperature, pressure, and humidity as they fall through the air mass, collecting information on the storm. We have a lot of people, we have a lot of instruments, and we had a historical hurricane season during a pandemic. So we had to mitigate those risks because we had to respond to the storm. And it was a lot of teamwork between everyone who supports us on the ground and with the crews. And to make that happen, our leadership took the initiative to implement a regular testing policy for everyone. We came up with contact tracing within the center, and we had a cohort system on the crews. So if one crew had been exposed to COVID, the other crew could still respond to the storm. With this approach, we were ready and capable to respond to every storm last season, and we will be ready to respond to whatever this upcoming season brings. Thank you for your time, and I look forward to your questions.
Thank you, Becky. Keep your camera on, and we'll have the others join you. Bethany, do you have some questions for our presenters?
Yeah, I do. I actually have quite a few, so I'm going to try to get to as many as possible.
Kyle, the first question is for you, and it's really interesting. This is something I hadn't considered, but if there's multiple ports impacted at the same time, how do you determine where to start recovery and survey work, obviously with limited resources?
Yeah, that's a great question. It really is a combined effort. Usually it's led by the Coast Guard districts. District 7 is who I normally work with, but Coast Guard sectors are broke up, or a district is broken up into multiple sectors. And if it's going to hit more than one sector, the district will get involved and make sure that there's enough assets. So between us and the Army Corps of Engineers, and there are a few private surveyors that are able to work as well, we just work spreadsheets to figure out, which is the top priority, and then which assets are going to be able to attack those ports in the best and fastest manner.
So a lot of collaboration, it sounds like. And Michael, question for you. How long does it take for the money to actually reach the fishermen or the fishing businesses after the event?
Well, that's a good question. It's a question that we often get. And unfortunately, when Congress gets involved, things seem to slow down considerably, unfortunately. And it sometimes takes up to a year. And we've had some disasters where funds have not come down for several years. But unfortunately, it's one of the detriments of this process, and we can't really figure out how to get that money back into the communities faster. But we try to do our assessments as fast as we can. We try to get the reports to Congress. We've made some big improvements in doing that. So at least that process is going well, but hopefully we can work on the other process and get that money into the hands of the people who suffered these disasters, because obviously they certainly need it.
Yeah, absolutely. Thank you. Kyle, another question for you. What is the most stressful part of the response? Oh, Kyle, I think you might be muted.
All right, a little delay there. Managing expectations definitely is tough. The port authorities, they want to get commerce running again, and it is needed to help with the recovery and get, especially when the fuel and other supplies need to come in. So really it's unfortunate to say it like this, but if the storm is really awful and everything is shut down for a while, we have time to do the surveys before the land side is able to accept a vessel. So it's really those mid-grade storms that are the worst, because the land side may be okay, but we really do need to check out what's underwater. So that's when the stress really mounts. But the captain of the port in each of the areas, really, they take the big flak, because it really does come down to their decision on when to open or continue to stay closed until the surveys come in.
Great, thank you. And Becky, next question is for you. It has to do with technology. What technology is being added to NOAA aircraft? Well,
That's a great question. There's a lot of technology requests that come from, the scientists, the researchers. In the first presentation, you saw some of the stuff that was coming from HRD, but we are constantly integrating new technology across all of our platforms, across the G4, our King Airs, which we use for emergency response, and our Twin Otters. So it's a pretty long list, but we just finished certification, or we're going through the process of certification, most recently for the Altius, the unmanned UAS, which is a pretty, contextually with the way that aviation is and the merging of manned and unmanned is a huge accomplishment. The idea that we're going to be able to fly an unmanned aircraft from a manned aircraft within a storm, when that capability is online, is going to be phenomenal. And even coming from the DoD, seeing that being rolled out is huge technology leap in general. We also are going to be launching the Alamo. It's been launched from Twin Otters and from the P3 and from the weather reconnaissance at the 53rd for the Air Force, and that's going to be taking data sort of ahead of the hurricanes on changes in sea temperature, and you can kind of start to watch the weather sort of ahead of the hurricane. But it's such a long list that I don't think I answered the question well. But those are some of the things that are coming online, and we're going to have more and more over the next couple months as our scientists get their requests to AOC.
Wow, that's really exciting. A lot going on. So I'd like to ask all of our panelists to come back on screen, and we'll come to, or circle back to a few of the questions that you folks had for a couple of the earlier presenters. One for Jennifer. Let's see here. Whoops, it just jumped away. What mediums for communication do you use with your core partners?
So we do email briefings initially before we are within the error cone. And then we will transition to webinars using GoToMeeting at this point. And the webinars are typically with each forecast cycle. And at the very minimum, they're twice a day. So we will be sure to update with all the latest while they're in their offices making those decisions.
Great, thank you. And Dennis, a question for you. I know this can be kind of a tough one too. Messaging of deterministic versus probabilistic forecast obviously varies by product. And the concern in letting folks know if there are most likely or worst case scenarios.
Wow. What we do in the messaging is we always convey the uncertainty. The first thing they're going to go to is the track forecast, and they're going to look at that and say, okay, that's where it's going. And the odds are very good, especially after about 24, 36 hours out, and John can back me up on this, is that it's not going to be there. Most times it won't be there. So we stick with more of a probabilistic forecast than anything else. John, you want to add some comments on that?
I'll just back you up, as you mentioned, Dennis. Yeah, so, because our forecasts certainly contain errors, we try to get people to not focus on the specifics and more the range of possibilities, and always refer them to Jen and other WFOs to sort of wheel in the specifics for their area.
Great, thanks, fellas. And I actually had a question that came in, so I'll tag team both of you again, because I think both of you might have a perspective on this. But the person wants to know, why don't public warnings emphasize the arrival time of tropical storm winds instead of, or in addition to, the time that the center of the eye makes landfall?
John, I'll let you start on that.
Yeah, they actually do. So the tropical storm warnings, when we put them up, it is when we think those winds will begin. That's when we're putting them up, rather than when the center will get there. So, it is confusing, though, I'll admit that, because there's an over fixation on a center position when hurricanes can be pretty big. But in the Weather Service, we definitely put up the warnings when we think the conditions will begin. So that's what it's intended to do.
Right, and the whole idea of the arrival of tropical storm force winds was to give people an idea of how much time they got to board up. That was the whole purpose of that graphic.
Oh, got it. Well, thanks for clarifying that. I know it's helpful for me to learn some of those nuances of being in the middle of the country and not having to deal with some of that as much. We've got time for just one more question. So Shirley, I'm going to pass this one to you because I think this is very fascinating as well. Are there hurricane ocean gliders that are still out in the ocean right now?
That's a good question. There aren't. So they are only launched for a particular amount of time and from particular areas. So we just, they launched the ocean gliders that were launched for AOML were launched off of Puerto Rico, north and south of Puerto Rico. And they were out there for about a month and a half. And then we collected them, and now they're back in our building waiting for the next hurricane season to start.
Wow, how exciting. Well, thank you so much. And these have all been really great questions. So thanks to the audience for that. It really helps us dive a little bit deeper and learn more. So Kelly, I'll hand it back to you now.
Thank you, Bethany, and thank you to all of our presenters. That wraps today's 3-minute thesis webinar on tropical weather. Please hang tight for one more minute to answer a few brief questions that will appear on your screen when you leave the GoToWebinar. Your feedback is crucial to help us plan future webinars like this one. And my thanks to all of our wonderful panelists. I hope you have learned something. I hope our audience has learned something and enjoyed these excellent presentations as much as I have. If you are interested in checking out past webinars, visit our new website, noaa.gov/central region, where you will also find more great information. Thanks again for your participation and have a great day.